Well, you've made it to week 15. Yay! It's almost over. Okay, so you have one last test, and I wanted to go over some of the concepts that you might see on test 3 and make sure that you're prepared and ready to go. All right, so we're going to start with the most missed concept. So let's see if I can get all of this on the screen here for you guys. Okay, so that looks bad. Suppose that 1800 is borrowed for 5 years at an interest rate of 5.5%. And it's compounded continuously. Okay, as soon as I see that word, I'm going to circle that. Find the amount owed, assuming no payments are made until the end. All right, do not round any intermediate computation. So that means don't round to the bitter end. And when you get to the bitter end, round to the nearest cent. So that's 2 decimal places. Okay, so on your cheater sheet, hopefully you wrote the compound interest formula down. So it's A, that's the amount owed, is equal to P, which is that principal, times E, that Euler, which is sort of a rational number, up to the rate times the time. So let's figure out what we need. So A is the amount of time or the final amount. So we're going to go with that's the final amount. We don't know what that is. P is the amount of time or the initial principal amount. So for us, the initial amount that we borrowed was 1,800 bucks. E is a constant, it's just Euler, so we're going to leave that. R is the rate. Remember, the rate has to be in a decimal. So they said 5.5%. So we're going to divide that by 100. So 0.055. That's our rate. And then time in years, what did they say? 5 years. So T equals 5. So we're going to do this in our calculator. Let's set this up first, though. So A equals P, which is 1,800, times E raised up to the rate times the time. Okay. Now, if you have a graphing calculator, this thing will do this all at once. So I'll show you that on the grapher, and then I'll show you like how to just do it on a regular calculator. So let's see if my calculator will actually turn on. Okay. Yay, it's come to life here. So if you have, let's make this brighter so we can see it. Oh, it did not work very well. Okay, so I keep on shifting over here, but I think it's just this. So I'm going to go 1,800. Okay, so I had to turn the lights on. That was helpful. So on the graphing calculator, you would just do 1,800, and then there's a E button here, right above the ln. So right here, E, it's right above the ln. So you get to that on the graphing calculator by hitting the second button and then the ln button. So I'll show you what that looks like. That helps you go up into the E land. And then it's 0.055, which is that rate times the time. So 2369 point, we want to go out 2 decimal places, so that 5 would make that 5 a 6. So we would have 2369.76. Okay, so I don't own a scientific calculator, but I am going to try my cell phone out, which is probably similar to something you might have, like your your scientific calculator. I'm going to turn mine sideways. Okay, so in order to do this problem on my calculator, I'm probably going to have to do it in pieces. So I would probably multiply these first, the 0.055 times the 5. So 0.055 times the 5. Get that 0.275, and I would rewrite this. A equals 1,800 times E to the 0.275. All right, now I probably would try to do this next on my calculator. So I might clear that out, and then I'm going to press E, which is right here. So somewhere on your scientific calculator, there's an E. And then this X to the Y tells me I can go up. So I'm pressing that and then 0.275. So I'm going to hit equals. Then I'm going to take that number and multiply it times 1800. And it should give me, yep, 2369.76. So you may have to use on your scientific calculators. Let's see if I can get this to look any nicer. You may have to use the E for Euler and then your x to the y so that you can get up into the exponent land, which is where you want to be when you're working with the continuous compound interest formula. So hopefully that was helpful. That now I see why is the most missed question because you might have trouble just getting that typed into your scientific calculator. So practice with this before you tackle that test because you're probably going to have something like that to deal with. Okay, so this one is always a surprise to me after 20 some years of teaching that we have trouble graphing vertical and horizontal lines. So this was the second most missed concept. So vertical or horizontal. So remember, vertical is up and down, horizontal is left to right, like the sun comes up on the horizon. Okay, so when they give you the graph, the line y equals -7, it doesn't look like y equals mx plus b, right? It looks very plain. We don't even see an x on here. So I always make a chart, okay? And what this is saying, if it could talk, it says I cross y at -7 all day long. So under the y, I'm just going to say, okay, so you're going to hang out at -7 all day long. So whatever value you put in for x, y is always going to be, this is like stuck. This is engraved in stone. Okay, so it doesn't matter what x values you have, -2, -1, 0, 1, 2, y is always -7. So I've given myself some coordinates, right? Come over -2, down to -7. Come over -1, down to -7. Start at 0, down to -7. Go over to 1, down to -7. Go over 2, down to -7. So this is what that line should look like. That's a horizontal line. You're just going to need to grab a couple points in that ALEKS program. All right, the opposite from that horizontal line is graphing a vertical line. All right, but again, let's look at this. See how this doesn't look like y equals mx plus b? So it's not going to be a line that looks like that or looks like that. So this is either going to be horizontal or vertical. This is saying I cross x at -2 every day, all day. That's all I do. So I just put x is -2. And then it doesn't matter what y values, -1, -2, -3. It could be, let's go in order here. How about -1, 0, 1, 2, 3. All right, let's not get crazy here. All right, sorry about that. That looks bad. So the main gist of this is set in stone. This is set in stone. This thing crosses X, here's your X axis, at -2 all day long, and it's going to be a vertical line. Let's see how that works. So come over on the X to -2, drop down to -1, over to -2, 0, over to -2, 1, over to -2, 2, over to -2, 3. So see how it's going to look like this? It's going to be a vertical line. This is vertical. And all it's doing is it's crossing X at -2, and that's what it does all day long. All right, let's look at another one or another type of missed problem. All right, we're going to do a couple of these. This is the third most missed concept, and it's just writing equations of lines. So I'm going to write out y equals mx plus b. This is your slope. You're going to need two things. You're going to need the slope of this line, and you're going to need the y-intercept, or where does it cross the y-axis. So let's find the slope first. I see that it's already given me 2 points here, so I'm just going to highlight those. Whenever I look at slope, I go from the top to the bottom and I start at the lowest dot and I try to get here. So maybe this is where I live and this is where I work. So I'm going to start here. So to go up, before I can go over, I have to go up 2. So that's up 2 hops. And then I got to turn on my signal and go 1, 2, 3, 4, 5, 6, 7, 8 hops to the right. So I rise 2 blocks and I run 8 blocks. So rise over run is 2 over 8. Okay, so up 2 over 8. Now 2 over 8 is a fraction. It reduces to 1/4, which if you wanted to, you could kind of see how that works. So if you started here and go up 1, right, and then over 1, 2, 3, 1, 2, 3, 4, you'll see that's another point on the line. That's 1/4. But 1/4 is the same as rising 2/8. So this is your m. So when I write the equation y equals, I'm going to replace the slope, that m, with 1/4. Don't forget to put your x here. These are going to stay stationary, right? They don't move. And then the last piece is, where does it cross the y-axis? So here's the y-axis, and it crosses at 1, 2, 3. So that's a +3. So that's how you write that equation of that line. This is your slope, and this is your y-intercept, or where it crosses the y-axis. Let's try another one. Write the equation of the line below. Okay, so I'm going to highlight my 2 dots. So I need slope and where it crosses the y-axis. So I'm going to go from the top to the bottom. The lowest dot is this here, so this is where I live, and this is where I go to work. All right, so I'm going to rise 1, 2, 3, 4. So that's a +4. So my rise is +4. And now I have to run. So after I go up 1, 2, 3, 4, I'm going to go over -1, 2, 3, 4, 5. So -5. So -5. The reason it's negative is because you're going backwards, right? You're not going to the right, you're going to the left. So up 4 over -5. So my slope is -4/5. That negative sign, by the way, the negative sign could be up here. It could be down here. It could be just in front. It means the same thing. If you were to think about it this way, right? So this is your rise and this is your run. You would go up 4 and over -5. If you think about it this way, you could start here and go down 1, 2, 3, 4, down -4, and then over 1, 2, 3, 4, 1, 2, 3, 4, 5, +5. Okay, so our equation is y equals -4/5. Don't forget your x. And then the last piece is, where does it cross the y-axis? So it crosses the y-axis. Here's your y-axis at 1, +1. So that's your equations, right? There's your slope and there's your y-intercept, or where it intersects the y-axis. Okay, that's the third most missed concept. Don't let that get you. All right, here's your fourth most missed concept. It's graphing a parabola, and the parabolas come in 2 different forms. They come in standard form. Standard form looks like ax squared plus bx plus c equals 0, or they come in, this is called vertex form. Vertex form is kind of nice, especially since they're asking us to plot 5 points on this parabola, the vertex, 2 points to the left and 2 points to the right. Then click on the graph a function button, which is this. Okay, so sorry, I want to fix my papers. So I'm probably going to find the vertex first. So the vertex is HK. That's the vertex. All right, so if we notice, there's a negative sign in this formula. This is just a base formula of vertex form, and a positive sign in front of the K. So if I write the same formula underneath that, I have y equals ax minus h squared plus k. So the vertex is right here. I'm going to circle it. So it's the h, which is that -1, but there's a negative sign in front of that h. So 2 negatives would make that a +1. So the vertex is 1, comma, and then k is positive, so we can go ahead and take that -3. So this is the vertex. So it's always opposite of h regular k. So the opposite of -1 is 1, and regular k is -3. So I'm going to graph that. 1, -3. So over 1, down 1, 2, 3. So we're going to label that. That's the vertex. That's the turnaround point on a parabola. Now the trick is they want 2 points to the left and they want 2 points to the right. So if I want 2 points to the left, I probably want to enter, we have where x is 1. Let's try x is 0 and x is -1. And then 2 points to the right, x would be 2 and x would be 3. So we can make a little handy dandy chart here, just like that. Okay. And that would give us 2 points to the left and 2 points to the right. All right, so we're going to have to put these values in for x into this equation 1, 2, 3, 4 times. So we'll start with, let's start with 3 for our x. So y equals 3 minus 1 squared minus 3. All right, so 3 minus 1 is 2. 2 squared is 4. 4 minus 3 would give us 1. Let's try 2. Y equals 2 minus 1 squared minus 3. And I'm just popping in these values for x into this equation. So 2 minus 1 is 1. 1 squared is 1. 1 minus 3 is -2. All right, so we have some points. Let's put 0 in. 0 is great. So y equals 0 minus 1 squared minus 3. So -1 squared is -1 times -1, which is 1. And 1 minus 3 would give us -2. And then let's put a -1 in there. So y equals -1 minus 1 squared minus 3. So -1 minus 1 is -2. -2 squared is 4. 4 minus 3 is 1. So let's see what this thing looks like. So we're going to go -1, 1, -1, 1, 0, -2. We have our 1, -3, and then we have 2, -2, and 3, 1. 1, 2, 3, 1. So when you hit this graph of function, it should come in and catch all those points, right? And we did exactly what they wanted. We did find 5 points, 1, 2, 3, 4, 5, 2 points to the left and 2 points to the right. So hopefully that's helpful. I can see why that also is a highly missed problem. It takes some work. And you got to be really careful. Okay, this is the 5th most missed problem, or this missed concept, I should say, on the test. And you can use the quadratic formula or factoring to solve for z. So what we're looking for, this is a parabola, right? So a parabola says z squared, so it crosses the axis twice. So it's going to look something like this. We're looking for these points here. What's that? And what's that possibly? Okay. So let's try, actually I wrote factoring twice. Let's try the quadratic formula. This thing always works, especially if you've learned it in this class. So quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And notice I put this line all the way under. Okay, let's go find the a, the b, and the c values so we can plop those in. So a value is always in front of the squared value, right? So if we were to write just a parabola's standard format, right, we would be ax squared plus bx plus c equals 0. So 1 is your a. Guess what? This is another reason why they were trying to trick you. This is not written in the right format. So let's rewrite that. It should be the squared term, which we have. Then we need the term with the x or the z on it. That's this guy right here. And then we need the constant, which is plus 60. Tricky, tricky, sneaky, sneaky. All right, let's try that again. A squared plus bx. Ax squared plus bx plus c. Okay, so our a value is still 1. B value is now negative 16, and C value is 60. Okay, woo. So let me put a little star here. This is tricky, all right, because it's not written in the right form. And so if they give it to you jumbled up like this, right, and in the wrong fashion, just move your terms around so that they're the squared term, the term with the z or the x, whatever, and then the term that's the constant that doesn't have a variable. Okay, so now that we know our a, b, and c values, let's put them into positions. So negative sign, b plus or minus b squared minus 4 times a times c, oopsie, all over 2 times a. So negative negative 16 just turns into 16 plus or minus. So negative 16 squared, well, that's just like 16 times 16. So that's going to give us 256. 256 minus 4 times 1 is 4, and 4 times 60 is 240, and 2 times 1 is 2. Okay, so we're going to keep going. X equals 16 plus or minus 256 minus 240 is 16. Okay, square root of 16 all over 2. All right, I need a little more paper here. Ran out of paper here. Okay, so what do we have? X equals 16 plus or minus the square root of 16 all over 2. Okay, we know the square root of 16 is 4. All right, we're almost there. So we're going to break this off into 2 pieces. X is equal to 16 plus 4 divided by 2, or X is equal to 16 minus 4 divided by 2. All right, so 16 plus 4 is 20 divided by 2 equals 10. And 16 minus 4 is 12. 12 divided by 2 is 6. So 10 and 6, oopsie, sorry about that. 10 and 6 are 2 answers. So we could do, like they usually give you some fancy brackets. So we could say 6 and 10 or 10 and 6, right? Doesn't matter. Okay, let's try it factoring. So we're looking for 10 and 6, right? We're looking for 10 and 6. So if we rewrite this as z squared minus 16z plus 60 equals 0, if we're going to go old school factoring, you're looking for 2 numbers that make 60 that you can make a 16 out of. So let's see here. We know that 12 times 5 makes 60. And we would need 2 negative signs here, because a negative times a negative makes a positive, and negative 12 minus 5 makes negative 16. So if we have these 2 factors, z minus 12 equals 0, or z minus 5 equals 0, and we add 12 here, z is equal to 12, which we didn't get here. We got a 10. So let me pause and see, what did I do wrong? I shall be right back. Something's not right. All right, I am back. So as I was rushing through this, because I know this video is getting long, I put 12 times 5 makes 60, which it does, but negative 12 minus 5 does not make 16, it makes 17. So I picked the wrong factors. We want 10 and 6. So let's think about that. So negative 10 times negative 6 makes the positive 60, and negative 10 minus 6 makes the negative 16 that we want. So sorry about that. So z is minus 10. I'm just going to clean that up a little bit. So my 2 factors would be, if you went the factoring route, z minus 10 and z minus 6 equals 0. And so let's cover that up. That looks so much nicer here. Okay, and then when you break these apart, z minus 10 equals 0, or z minus 6 equals 0, and you add 10 to both sides, and add 6 to both sides, z equals 6 and z equals 10, which is what we found when we did our quadratic formula. So probably you're going to want to stick to quadratic formula because factoring is a whole nother skill that's not really covered in MAT 205, at least not thoroughly. So for those of you that are wondering about this factoring, if you have any recollection at all of Algebra 1 or Algebra 2 back from high school, you could do something called FOIL here. So I have two factors, and I can check to make sure that this does turn into z squared minus 16z plus 60. Because you could multiply the first terms, that's what the f means. So z times z is z squared. Then you can multiply the outer terms, z times negative 6, negative 6z. Then you can multiply the inner terms, negative 10 times z is negative 10z. And then you can multiply the last terms, negative 10 times negative 6 is positive 60. And then you have some like terms here. So we got z squared, and these combine together to become negative 16z plus 60. Okay. Was that it? Yeah. So best of luck to you on test 3. It has been an absolute pleasure serving as your instructor this semester. Email me anytime. Good luck. Bye.